5.2, we're looking at polynomials. We're going to look at a lot of topics you've seen before in Algebra 1. We took different lessons on adding and subtracting polynomials in Algebra 1 and multiplying polynomials. We're going to throw them all together at one time now. How can polynomials be applied to financial situations? Shaniqua wants to attend Purdue University in Indiana, where the out-of-state tuition at the publishing of this book was $8,820. Suppose the tuition increases at a rate of 4% per year. You can use polynomials to represent the increasing tuition costs. If r represents the rate of increase of tuition, then the tuition for the second year will be 8,820 times 1 plus r. For the third year, it'll be 8,820 times 1 plus r squared, or 8,820r squared plus 17,640r plus 8,820 in expanded form. This expression is called a polynomial. A polynomial is a monomial or a sum of monomials. The monomials that make up a polynomial are called the terms of the polynomial. In a polynomial such as x squared plus 2x plus x plus 1, the two polynomials 2x and x can be combined because they are like terms. The result is x squared plus 3x plus 1. The polynomial x squared plus 3x plus 1 is a trinomial because it has 3 unlike terms. A polynomial such as xy plus z cubed is a binomial because it has 2 unlike terms. The degree of a polynomial is the degree of the monomial with the greatest degree. For example, the degree of x squared plus 3x plus 1 is 2, and the degree of xy plus x cubed is 3. Determine whether c to the fourth minus 4 square root of c plus 18 is a polynomial. If it is, state the degree of the polynomial. Well, it's not, because in lesson 5.1 we said that a polynomial could not have variables under the radical sign. And we know in general if they give us two examples of the same thing, if one doesn't work, the second one does. So this expression is a polynomial. The degree of the first term is 5. The degree of the second term is 2 plus 7, so 9. And we want the degree of the highest term, so the degree is going to be 9. To simplify a polynomial means to perform the operations indicated and combine like terms. We have 2a cubed plus 5a minus 7 minus a cubed minus 3a plus 2. We could start off by distributing that negative 3. The first set of parentheses is not doing anything, so we don't even need them. Minus a cubed minus negative is plus 3a minus 2. Now, if you like, it's nice to use the commutative property and sort the like things together. So I have 2a cubed minus a cubed plus 5a plus 3a minus 7 minus 2. And then you can add and subtract. 2a cubed minus 1a cubed is 1a cubed. We don't normally write the 1. 5 plus 3 is 8. And negative 7 minus 2 is negative 9. Notice when we are combining like terms, the coefficients are the only things that change. The variables have to be the same variable raised to the same power, or we can't combine them because they are not like terms. In Algebra 1, we also learned how to use the distributive property. So negative y times 4y squared is going to be negative 4y cubed minus 2y squared. Negative times negatives are positive, so plus 3y. When we multiply two binomials, we can use a method called FOIL, which is a step up from a distributive property. So we have the sum of the products of the first terms, outer terms, inner terms, and the last term. First times first, we've got 8p squared. Outer, or I say first times last, 2p. Inner, second times first, plus 12p. And last, I got in the habit of stacking my like terms. It's handy because it emphasizes they are like. And if we're using our little boxes to do homework, it also fits in the box nicely. Hey, two binomials, we can use a cool little acronym FOIL. It doesn't work if we have trinomials involved. So we're just going to take first times the other two plus the second term times the other two plus, oops, the third term happens to be a negative, times the other two terms. I don't normally write it out like that. I normally kind of do the little arrows thing. But, you know, show it this way for once. So a squared times a, I now have three factors of a, plus 2a squared plus 3a squared plus 6a minus 4a minus 8. So happens to be our like terms ended up next to each other. That's handy. So 2a squared plus 3 more a squared is 5a squared. And 6a minus 4a is 2a minus 8. And our like terms are combined, so we're done. I think this lesson took us about a chapter in Algebra 1 that we just went over in one lesson. In Algebra 2, adding and subtracting polynomials, we combine like terms, multiply polynomials by using the distributive property, and special case for binomials, you can use the FOIL method.